So I wanted to go over a few problems in Module 3, Lesson 2. This is about the multiplication rule. And just the general idea is when you have a sequence of events and you want to find the probability that all of the events happen, you multiply probabilities, right? That's what this section's about. But I want to go over a few problems here. Okay, so let's look at number 8. Two cards are selected from a standard deck of 52. The first card is not replaced before the second is selected. Find the probability of selecting a 6 and then a king. All right, so the key word in this section, lesson 2, is and. All right, all these problems are going to have an and. And that means you want to find the probability that both the first event and the second event happens, and you multiply them. All right. So the probability in this case of A and B is probability of A times the probability of B. And you know if these are dependent, then this is equal to the probability of A happening times the probability of B happening given that A happened. Don't worry too much about that. This comes out in the wash in the problems, and we'll do this one here now. What's the probability of selecting a 6 and then a king, right? So we're going to want a 6 and then a king. All right, well, that's going to be the probability of getting a 6 times the probability of getting a king. All right, this is the multiplication rule, we're multiplying, right? So what's the probability of getting a 6? Well, how many 6s are there? There's 4 6s in a deck of cards, all right? So this is the total number of cards, 52, and there's 4 6s, so we're going to have 4 possibilities in the numerator times. Now, here's where the probability of getting a king is dependent on this event because we take one out, right? This, since it says without replacement here, where is that? Is not replaced. We're going to take one out, and now we only have 51. So now the probability of getting a king, there's 4 kings out of 51, right? So the probability of getting a king, given that I already took one out, is now 4 out of 51. All right, if we do that math there, let's see here. 16, well, 4 times 4 is 16, divided by 52, 0.006. All right, 0.006. All right, so the key is here, you see the word and, that means you're going to multiply, and then you'll have to figure out the probability of each one of these events. And if they're dependent, in which case this is, you know, we picked a 6 out, we're going to have to remove one card out of the denominator here, but we didn't pick a king, so we're going to continue using 4 kings. All right, let's try number 9. All right, here's a chart of credit card carriers. All right, if a student is selected at random, find the probability that he or she owns a credit card given that the student is a freshman. Round your answer to 3 decimal places, right? So given that the student is a freshman, where's that? Okay, so that means we're going to start with this row right here. Given that they're a freshman means they're going to be in this group of 60. All right, we're not going to count these 40 here because they're not freshmen. So given that they're a freshman, all right, what's this? Find the probability that he or she owns a credit card. So the probability of having a credit card given that they're a freshman, all right? So given that they're a freshman means the denominator is going to be 60, all right? And then we need to find how many of those 60 have a credit card. It looks like 14, right? 14. So 14 out of 60. 0.233. 233. Okay. All right, so next one, number 11. Okay. So I want you to kind of understand that this is one of the problems that occurs on the tests and quizzes, and it basically has at least 3 parts, all right? The first part is that both events happen. The second part is that neither event happens. And then the third part is at least one of the events happen. Okay, so that's the structure of these. You won't see this. For example, you'll see this one at a time here, and this will be both, all right? And then the second one, the second part will be neither. And the third one will be at least one. Okay, so let's go ahead and do this problem right here. A sheet of paper. All right, so, all right, let's start out here. All right, in a sample of 800 adults, 199 think that celebrities are good role models. All right, so the total is 800, and good role models, out of the 800, 199, all right, thinks celebrities are good role models, which you know is kind of low, obviously. Okay, let's do this first part. Find the probability that both adults think celebrities are good role models, all right? So what we're going to have 2 events here, all right? I'm going to randomly select someone from this 800. What's the probability that this first person I pick thinks celebrities are good role models? And then I'm going to do it again, and I'm going to multiply, right? Both means this and that. That's the multiplication rule, all right? So the denominator is going to be the total. Oh, well, let's see. Is there a replacement? Without replacement. That means the second one here is not going to be replaced. So I'm only going to have 799. All right, so we're going to have 199 here, right? Out of 800, 199 think they're good role models. But then this first one here, I'm going to pick one from here. So that's only going to leave us with 198 because one of them was chosen on this first selection. All right, so that's going to make the total left 799, and now there's only going to be 198 left. So let's see what that comes out to. 198 times 800 divided by 799 divided by 0.062. All right, 0.062. All right, so that's the first one where both you multiply, but you have to consider what happens here, right? When you don't replace, you have to change these numbers. Now, the next part is not a good role model, all right? Well, if that's going to be 1 minus the probability of picking someone that thinks they're a good role model, all right? So that's going to be 1 minus 199 out of 800. That's the complement, right? So that's going to come out to be, all right, so this just goes 601. This is like 800 over 800. If you want me to write that out, that's like 800 minus 199. All right, so that's going to be 601 out of 800, which is 0.7513. All right, that neither, all right, so now neither. So the probability of not a good role model, and then now I have to do that twice and multiply it because the first one didn't think they were a good role model, and neither does the second one. So the first one again is going to be 601 out of 800. But then, when I choose the second one, all right, I'm going to remove 1 from here. And since the person I chose is going to come out of this group, there's only going to be 600 of them left. Right? So the first one's not in the group that does not think they're good role models. And then the same group, -1 for the second person. So let's do the math there. 601 times 600 divided by 800 divided by 799. So that's going to be 0.5641. All right? Okay, so now this one we have both. This one is neither. All right, so that's the second part, A, B, and then the third one is at least 1. All right, so these problems, they all have that structure where it says both, and then neither. All right, neither, and then at least 1. And the formula for the probability of at least 1 is equal to 1 minus this one, the one in part B, the probability of neither. All right, because one of them, at least one of these, happens. Okay, so just know that what you basically do is you subtract this from 1. So this is going to be 1 minus 0.5641, or I think it's just 0.564, yeah, so 0.564. And that's going to be 0.436. All right, 0.436. All right, so just make sure when you see these problems, like there's a method to this, right? There's a method to this, and this is what you do over here. Okay, you find out the probability of both, and then you find the probability of neither, and then this last part, at least 1, you subtract whatever you got in part B from 1, and that's your answer. Okay, let's look at one more. Okay, according to a study, 87% of K through 12 schools or districts in a country use digital content. Of these 87%, 10 out of 20 use digital content as part of their curriculum. Okay. Find the probability that a randomly selected school or district uses digital content and uses it as part of their curriculum. All right. So let's see if I can fit this up here. So this is, what's the problem? Again, read the problem. I know I kind of run through these, but always say, find the probability. What is it that I'm looking for? It says the probability of what? That a randomly selected school or district uses digital content, all right, and it uses it as part of their curriculum, all right? So that's going to be, given that they use it as digital content, do they use it as part of the curriculum, all right? So that's a little bit confusing on the way they worded this problem, but these problems, remember, we're doing the multiplication rule, all right? So let's find out what these numbers are and multiply them. All right, so the first one is, what's the probability that they use digital content? That's going to be 0.87, right? It says 87%. And then given that they use digital content of these, all right, 10 out of 20 use digital content as part of their curriculum. So it's just going to be 10 out of 20, right? So this probability is just, if they're in this group, then half of them, 10 out of 20, use it as part of their curriculum. So if you do that math here, it's 87.435. Okay. I guess just to let you know, these are a little bit convoluted. There's a lot of words in there. Look for the word and. Where's the word and? Find the probability that one thing happens and the other. That just tells you you're going to use the multiplication rule. Look for your numbers. You're going to multiply the first number by the second one here. All right, 10 down to 20. I hope that helps you. I know that was a little bit confusing, but if you have questions, go back, watch the video slowly, and if you still have questions, send me a note, okay, or send your instructor a note. Thanks.